In this module, we will go over the process of learning parameters. Gradient descent is a method to find the minimum of a function. It can be applied to functions with multiple variables. But let's look at our little toy example problem with just one dimension and one sum. If we start off with a random guess for the parameter, where we use a superscript to indicate the guessed number, in this case 0. We would like to move our guess in the positive direction. We can do this by adding a positive number to the parameter value. Examining the sign of the derivative, it is the opposite sign of the number. Therefore, we can simply add a number proportional to the negative of the derivative. Subtracting the derivative works if we are on the other side of the minimum. In this case, we would like to move in the negative direction. We can move in the negative direction by adding a negative number. Examining the sign of the derivative, it is the opposite of the sign of the number we would like to add. Therefore, we can simply add a number proportional to the negative of the derivative, as in the previous example. In gradient descent, we recursively calculate this equation. We start off with the initial guess. We update the parameter by adding a number proportional to the negative of the derivative. We update the parameter again. We repeat the process, which is represented by this recursive equation. The parameter eta, i.e. the learning rate, tells us how far we would like to jump. Let's clarify this with an example. The initial value for the derivative at this point is negative 112. We will use the following learning rate. We calculate the first iteration. The resulting value for the parameter is 1.6. The value has a smaller loss of 50. We can see the loss value for the first iteration is smaller than the initial value. For the next iteration, we start off with the previous parameter estimate of 1.6. We update the parameter value by using the update rule. The result is negative 0.4. We can see the loss value is smaller, and the loss for the second iteration is smaller than the first iteration. One way when to know when to stop gradient descent is to see when the loss starts increasing. Let's compare the loss values in the following table. For the initial value, our loss is 250. We calculate the first iteration, and the value of our loss is 150. Comparing 150 to 250, we see it is smaller. As a result, we keep going. We calculate the second iteration. The value for our loss is 50. Comparing the value of 50 to the value obtained from our first iteration, the value is smaller, so we keep on going. For the third iteration, our last value is 100. As 100 is larger than 50, we stop. We use the parameter value from our second iteration, which in this case is negative 2.5, which generated a loss of 50. One problem is selecting a learning rate. In the last example, we selected a learning rate of 1 over 20. If we select a learning rate of 1 over 5 and update the parameters, we see the value of the loss is increased. We can't really even fit it in this screenshot. Another problem is choosing a learning rate that's too small. Consider the learning rate of 1 over 240. After running the first iteration of gradient descent, we see our first value has not changed so much from our initial value. Running it for a second time, we see the parameter has not changed a lot. This will take a long time to converge, or a large number of iterations to reach the minimum. We will discuss how to select the learning rate in another section.